This video demonstrates how to use different types of contact and coil instructions when programming an Emerson RX3i PACSystem controller. We're using an IC695 CPE 305 and we're programming this controller using Proficy Machine Edition version 9.5. This video explores normally open and close as well as transition contacts and coils, set coils, reset coils, and then continuation coil contact pairs. So without further ado, let's get started. Here we have Proficy Machine Edition 9.5 running. Our controller is in programmer mode and the controller is running with outputs enabled, with configuration equal and logic equal. Now in the PLC ladder ribbon, let's get started with a few simple normally open and normally closed contact instructions. So I'm going to click the normally open contact instruction and just click it here in my first rung of my ladder diagram main routine. And on the far right, we're going to add a coil. Let's call this contact instruction, let's call the variable that we associate with it contact 1, and the coil, let's call it coil 1. And then just below it, let's add a normally closed contact, and let's create another coil, and we'll call this coil 2. And we're going to call this, we'll just use the same variable. Okay, so let's accept these rung edits. Now it's important to understand too, logic is executed from top to bottom and left to right in ladder diagrams. So we can see here, because this contact 1 variable is associated with a normally open contact instruction, power is passed from left to right whenever its Boolean value is set to true, and it is, it's 1, it's on. Now, because of that, the coil instruction, whose variable associated with it is coil 1, is set to true because, again, its value is driven from the upstream contact. Now, if I were to toggle this to 0, we can see that the coil has de-energized, and therefore the variable, coil 1, associated with it is currently off. It's false. But the inverse is true when using normally closed contacts. So we can see here that contact 1 is currently off, but power is being passed, because we're using a normally closed instruction, a normally closed contact. And therefore, the coil at the far right, which is coil 2, that's the variable associated with it, is therefore energized. And if we just toggle that again, we can see de-energized, and of course we're just flipping between the two states because we're using the same contact variable for these normally open and closed contact instructions. Now, let's talk a little bit about positive and negative transition contacts. So suppose I were to, say, remove the second rung, and in its place, let's create a positive transition contact. That's POSCON, is the short form. And let's just grab this variable coil 1 and paste it here, so we're associating it with this instruction. And on the far right, we're going to use a move integer instruction to move a 5 into a variable called integer every time power is passed from left to right. So let's accept this. And we can see that contact 1 is currently energized, and the coil 1 is therefore energized, but we're not passing a 5 into an integer. And that's because this only executes whenever whenever the Boolean variable associated with this instruction transitions from 0 to 1 or off to on. Now, since the last scan has completed, we have actually kept this variable in Boolean 1. It hasn't changed value. But if we toggle this to 0 and then toggle to 1, now we've moved from 0 to 1, now this executes. And it doesn't keep executing, it's going to stay as it is until the next time this transitions from 0 to 1. So let's make it a 0, and let's make it a 1, and there we go, it executes. Now the inverse is true with negative contact instructions. So let's just change that, we're going to apply this, and now this will execute, meaning power is passed from left to right, and the move instruction is executed whenever the variable, coil 1, moves from 1 to 0. Now currently it's 1, so if I just write a 10 in here, this is not going to execute, but now if it moves to 0 by toggling the contact, now it moves to 0. And if I write a 10 in there, it's not going to execute again until it moves from 1 to 0. So let's make it a 1, and let's make it a 0, and it executes. So those are the quick differences. Now we've talked a little bit about normally open coils, since we're using that in our first rung on the far right, but how about normally closed coils? So let's just remove this logic, and let's just copy this contact over here, and we'll make a coil over here at the far end, but we're not going to use the coil instruction, we're going to use a normally closed coil. So let's just replace this with NC coil, and we're going to give this a variable associated with it, and we're going to call it coil 2, and we're going to accept this change. And now it's kind of the inverse of a typical normally open coil, or just a coil. Whenever no power is passed to the instruction, its value is true. But as soon as power is passed, its value is false. It's basically a normally closed contact, but instead it's a coil. Now, let's talk a little bit about positive and negative transition coils, as opposed to what we talked about earlier, positive and negative transition contacts. So let's go ahead and let's switch out this normally closed coil, and instead in its place we're going to put a positive coil, or a positive transition coil, and we're going to call this pos coil, and just create a variable for it, and then just below this this rung, we're going to create a normally open contact, and we're going to call it with the variable pos coil. And then on the right hand side, we're going to create a move instruction, in this case a move integer instruction, where we want to move a 20 into a variable called integer each time power is passed from left to right. So we're going to wait. Okay. Now what will happen here is, as soon as power is passed from left to right, this positive transition coil will set its associated variable to true just for one scan, and then it goes back to false. So we can see here, since our first scan has taken place, because this is true, power is passed from left to right, the variable pos coil is set to 1 for one scan. Then on the next run, because it's going to be a 1, this move instruction is executed because power is passed to it, because we're using a normally open contact, and then the next time it scans, the variable associated with this coil will be set to 0 until this re-executes, meaning we'd have to set the contact 1 variable back to 0 and then back to 1 again. So for example, if I set this integer to say 10, it's not going to re-execute. We got to set this back to 0 and then toggle it again, and now the positive coil has transitioned back to 1. The variable is now set to 1 and power is executed. This power is passed from left to right on the next rung, and we've set our integer to 20. Now how about negative transition coils? So we're going to enter this as a negative coil, and let's just accept rung edits here. It's the inverse. When it comes to negative transition coils, whenever it receives power and its associated variable has transitioned from 1 to 0 since the last scan, then its associated variable is set to 1 or on for one scan. So we can see here, if I set this integer to say a value of 0, we can see that it's still a 0 until the variable pos coil is set to 0. It has to transition from 1 to 0. So if we toggle the upstream contact, now it's going to be 0, and because it's 0, power is passed on the normally open contact, and the move instruction is executed. Now if I make this contact back to 1, now power is being passed, and as soon as we lose power, then the negative transition coil will execute once more time, and we'll see the integer get overridden with a value of 20. Perfect. Finally, or rather not finally, just a few more instructions to cover. Let's look at set coils and reset coils. So let's go ahead and just skip down here, and let's create a contact, and we're going to give it a name of contact 2. And on the far right, let's create a set coil instruction, and we're going to call this coil 3. And just below contact 2, we're going to create another instruction, a normally open contact, and let's give this a name of, say, contact 3. And in this case, on the far end, I want to use a reset coil and with the variable coil 3. And let's save this and accept those edits. So what happens here, whenever we use a set coil, it will set the variable associated with it to a value of 1, and when it doesn't receive power flow, it just leaves the variable alone. Unlike a coil, where if you lost power to it, then its associated variable will be set to 0 because you've lost power. But in this case, it just leaves the variable alone. So if I were to write, say I were to write a 1 to this contact 2, now we're passing power, and as expected, the coil 3 variable is set to 1. But if we lose power, it leaves it alone. It's not being set to 0. So the set coil is doing its job. Now, if we were to energize the next rung by toggling contact 3, this variable, the reset instruction will occur, and then it will reset the variable associated with it back to 0. And if it's not receiving power flow, it just leaves the variable alone. So what this means is, if we were to toggle this, there we go, we can see that coil 3 has a Boolean value of 0, and when we don't have power flow, we can see that if we toggle this coil 3 variable to, say, a value of 1, we can see the reset instruction is just not going to execute. But if we toggle the upstream contact, then it will, and it will reset the value of the variable coil 3 back to 0. Now, finally, I want to talk a little about continuation contact coil pairs. So suppose I had a normally open contact here, and suppose you had a whole bunch of logic in between this contact. Instead of using a coil at the end, let's use a continuation coil. Mind you, I'm going to just copy this variable here so we can just share its variable name. And then on the next rung, we're going to create a continuation contact. And on the far right, we're going to create a coil. And in this case, I'm going to call the coil variable associated with this contact, with this coil variable coil 3. So let's accept these changes. And what's going to happen here is, as soon as contact 3 is energized, it passes power from left to right because it's a normally open contact. Then once this this continuation coil instruction executes, then it will just continue to pass power to the next rung because we have a continuation contact because the prior rung has received power. So it's good to break up your logic if you want to use continuation coil and contact pairs. So if I just toggle this contact 3, we can see power is passed and coil 3 is energized. And if I toggle contact 3, coil 3 is de-energized. And as you can probably imagine, you can put a whole bunch of continuation coil contact pairs in between. As long as they're there, it's going to continue passing power until you finally reach the last rung with just a continuation contact. So we're going to accept this. And we can see that when we're going to toggle the I/O for contact 3, we should see coil 3 energize. So there we go. So power is passed left to right. This executes. Power is continued to pass. This executes. Power continues to pass. This executes. Power continues to pass. This executes. So that's about it when it comes to contacts and coils. I hope this video was instructive and helpful for you. And thanks for listening and watching.